Okay, today we are going to start a review of transformations. So most of this you learned in IM1. The first thing you want to do is identify your parent equation. They will usually tell you what it is. Now, we need to know how we're transforming, and we learned a lot of different transformations, but today we're going to talk about translations in this couple of slides. So translations are up and down is vertical, and side to side is horizontal. Just looking at a graph, we can only tell which way, especially a linear graph, which way it's moving if we have a corresponding point. So they gave us these corresponding points, so we know that this is a horizontal movement. Another thing you need to know how to do for translations and all transformations is to map them. So the map always starts with this. This tells you that we had a starting point and we're changing it. That's how you're mapping it. This part over here is telling how you change the coordinate notation. For example, this is saying take every x and subtract 3. Don't change the y. So if I went to this point here, which was 3, 3, I would change it to 3 minus 3 is 0. The y stays the same. So if you look at your picture, you can see that that is this point. So we did okay. Okay? And that again, because the change is only on the x, is telling you it's a horizontal translation. Because think of it, when something's moving this way, your y stays the same, but x is changing. Another thing you need to learn to know is that to give the new equation in function form. So here's the name for my original equation in function form. Remember, function form means you take the f of x and substitute that for y. Those are the same in the equation. Okay, that's just putting it in function form. But I need to give my new function, and this time I'm working with this one, so I'm going to give it a new letter out here, because it's not the f of x anymore, it's a new letter. You can use any letter you want. Avoid L because it looks like a 1. Don't use I because we're going to use I later on. Just don't make it x or y. Okay? Now, when they showed it here in parentheses, notice that that's different than this. This is the equation of this line. The reason that they put it like this to show you the transformation is to tell you that it's horizontal. In a transformation, the variable that they use is called the argument. When a change is only on the argument, like this one is, it's only affecting what's inside the parentheses, then that's telling you it's a horizontal movement. If I wanted you to move it up, then I would write it like this. And that would be up to. Okay, so it would be not in parentheses. Okay, and then the last thing you want to know how to do is to write it in terms of the original function. So for this one, I'm going back to the red line, and I'm giving it a new name, and I'm saying this new equation, which is the h of x, this new graph, is the same as the f of x, except for this. So you write the f of x. Because it's a horizontal movement, I put it inside the parentheses. Now another thing you might have noticed is that for a horizontal movement, left is plus and right is minus. So you intuitively have to know that and remember that. For a vertical movement, up is positive, down is negative, which is a lot more intuitive. So this is just something you have to remember. Okay, so this is just going to go through the rules really quick. The argument of a function is the variable on which the function operates, usually x. A horizontal translation, and when I'm doing these on a test, I just write myself a little drawing to remind myself what a horizontal translation is. That means it's shifting the entire graph left or right, so that means only the x is affected. So the equation g of x is a translation of f of x 2 units twice, 2 units right. So I would write that like this. The g of x equals the f of x, right would be minus 2, like that. Okay? Now, when I'm mapping it, it's going right to, so my x is going to go this way. So notice that these are not the same. Okay? We're going in a different direction. So this is telling you it's a horizontal movement right. This is telling you that x is moving right. So they agree. Okay? They look different, but they agree. So make sure that your map agrees with your function. And then the new equation could be written like this, or like this, to be more precise, to show that it's a horizontal function. The problem is, I could write an equation like this, and I will get the same line as this. So how do I know if I went up and down or left and right? I have to look at those corresponding points. That's the key. Okay, and then the new function looks like that, which is what I wrote there. Okay, now we're going to go with vertical. So if you're taking a test, to remind yourself you're moving this way, that just helps you remember that only y is changing now. Okay, that's what the coordinate is. Okay, if this is my parent function and I wanted to write this one, this is the description that they're giving you. And now we're going to do the other things. So the first one is the map looks like this because I'm going down 3. So that's going to change my y, down 3. Okay? Those agree. Vertical is going to be the same. Okay, then I'm going to draw my graph, and it's going to look, or draw my new equation, write my new equation, and it's going to look like this. This time, since x minus 3, and I'm seeing that y changes, that's telling me that this is a vertical movement. Okay, and these are going to agree. The new function in terms of the original function would be written like this. Because it's outside and affecting the whole equation, it's not just affecting just the argument. That also tells me that it's a vertical change. Okay, stretch and shrink is a term you're going to hear this year, so you've got to be familiar with it. And the best way to describe it is the relation of a function to the x-axis. Most of the ones we're going to deal with this year are vertical stretches and shrinks. So a vertical stretch is when the line moves away, so it gets farther away from the x-axis. Okay? Farther away. So on a parabola, this would be my point. A stretch would take me up, like this. So it's getting away from the x-axis. A vertical shrink is when the line comes back this way. It's getting closer. It's shrinking down, or the distance between the line and the x-axis is shrinking. So for a parabola, it would look like that. The parabola would start to grow faster. And remember, a parabola is going to be symmetrical, so it's going to be like that. Okay? So it's getting closer to the x-axis. We don't deal a lot or at all with horizontal stretches and shrinks, but I just want you to know, because this was taught in IM1, a horizontal stretch means you're stretching your graph horizontally, but it's shrinking down to the x-axis. So it's the opposite of what you're thinking. Okay? So a horizontal stretch, a shrink is going like this. No, the other way around. So just remember that. It's the opposite meaning, and it's the relationship to the x-axis. Okay, how to show those? So here's my parent function. If it's inside, and this is where you have to be careful, if it's inside with the x, then that means it's horizontal. With a horizontal, a fraction means a stretch. And a whole number means a shrink. Okay? If it's a vertical stretch, it's going to affect the whole thing, so it's going to be out in front multiplied by your function. And a whole number means a stretch, and a fraction means a shrink. And the easiest way to remember this is with the slope. So if I had x equals y, or y equals x, and then I changed it to y equals 3x, then that's going to go like this. Oh, it's stretching away from the x-axis. If I say y equals 1/3 x, my slope is now up 1/3. It's going to be going like this. It's shrinking back down. So just know that that's the change and how you can remember it. Okay, the next thing you want to do is open your journal to page 1, and you're going to do these 5 problems. You're not going to be graphing them, you're just writing down what was the translation, and then you're going to give the map. Now that I've given you the instructions, push pause. When you're done with the problems, then hit go again. Okay, so there's your answers. If you have any questions, we can talk about them tomorrow in class or on the next time we meet. So this is just a real quick reminder about what a reflection is. If we have a reflection over the y-axis, here's a point, and we reflect it over the y-axis, that's moving horizontally. If we have a vertical reflection, then we're moving over the x-axis. Okay? This is a reflection over the line y equals x. So the first thing you want to do is graph that line. This is y equals x. If we want to write it in function form, the f of x equals x. Okay? The next thing you want to do is, this is problem number 6, we want to graph it and decide what shape is it. So we graph that, we put the 2 points, and we graph that. And we notice what shape it is. This is a segment. That's important because transformations, with the exception of dilations, preserve the size and shape. So our shape will be the same. Okay? Alright, so the next thing we want to do is we want to remember what the map is. So if you want to know what the map is for a translation over y equals x, it is this. And so I'm going to take point L, which is 2, -4. That means that will be -4, 2. And that's my L prime. So I'm going to graph that. 1, 2, 3, 4, 1, 2. And that is L prime. Then I'm going to take M, and I'm going to go 2, 0, and my M prime is going to be 0, 2. So 0, 2 is right here. And now we check to see if their answer is correct, and it is. So you might want to practice with reflections too. So that is the end of the video, and good luck with the homework.